Okay, so welcome to all of you. It's very nice to see some familiar faces, some not so familiar faces. So this is our first ICE talk. ICE stands for the Institution of Contemporary Ethics. We are a very newly established institution aimed at producing research on contemporary issues in ethics, mainly from a philosophical view, but we are also very interested in having conversations across the social sciences and humanities especially. Our definition of ethics is quite broad. So in short, it is aimed at the provision of research and practical applications to the complex challenges resulting from the intersections between humans, technologies, and environments, whatever those environments may be. And our aim really is to try to find more ethical ways to live meaningful, just lives. So I'm currently the chair of ICE, and I'm also an associate professor at the Northwest University in the School of Philosophy. My own research converges on basically critical algorithm studies, the philosophy of Deleuze and Guattari, anarchism, and continental philosophy more broadly. And so just to let you know, we don't have a website yet. We are currently working on that. So I'm very much hoping that we'll have one in July by the time of the second talk. So I'll let you know. And if you're interested in knowing about our talks, please feel free to leave your email address in the chat box. I'll collect them and I will send you notifications of our following talks. So with me today, I have Elena Esposito and Nico Buitendag. And so I assume that many of you are familiar with Elena's work and perhaps especially her new book, Artificial Communication. And so Elena is a professor of sociology at Bielefeld University and the University of Bologna. She works in the field of social systems theory. She teaches general sociology at Bielefeld University, and she also then teaches the prediction and future of public policy at the University of Bologna. Elena, welcome. We are very excited to hear about your work. And then just let me introduce Nico. Also, Nico Buitendag works at the Northwest University. He's a postdoctoral fellow at the Faculty of Law. His research focuses on legal and political theory and attempts to engage radically with social systems theory. And so during his doctoral studies at Kyoto University, he was also a research fellow at the Niklas Luhmann Archive in Germany. And so the way our talk will work today is that Elena will start, she will give a presentation, after which Nico will respond to her with just a few questions. And once that's done, I will open the floor to any other questions that we may have. Okay, so at this point, I'm going to give over to you, Elena.
Thank you so much. Thanks, Chantelle, and thank Nico. I'm really, really happy to have the opportunity to present my research here in this group in such a great program. And as you will see, what I'm presenting here is a theoretical background of what I hope will become a research program devoted to addressing more concrete questions. I will present a couple in the debate, but I'm really, really thankful for feedback and for exchange because it's really needed in this time. I have a simple PowerPoint presentation. Maybe I should share the screen by now. Ready, Chantelle? Yeah, I'll do it. Okay, seems to work, great. So the titles, Algorithms as Communication Partners, is what I will discuss mainly here. But I have to say that this is a slide that I have to present because I'm by contract, but I'm really thankful to have to do that. I have to thank the European Research Council, which is supporting a project with the name PREDICT, or more concretely, the future of prediction, that I will be leading the last 5 years. But I mentioned also, I'm happy to mention it here because it's really perfect to discuss it in a program called, as yours, Think in the Future. I think there will be a lot of overlapping about the question that I want to address on the background on this project and connect you to the question I will be presenting here. But today, we want to talk about this specific, quite basic question that has been asked all the time: have algorithms become intelligent? This is, of course, not a new issue. Research on automatic information processing has always been driven by the idea or the hope or the project of reproducing with machine human intelligence, as the very label of artificial intelligence presents. And this project has accompanied the progress of digitization since its very beginning in the 1950s. You all remember Dartmouth Conference, where the idea was generated, with different outcomes, with alternating success and disappointment, marked what have been called the winters and spring of artificial intelligence. Winter, when one found problems; spring, when hope was developing, and one thought we are getting closer to the idea of realizing this form of artificial, of reproducing with machine the forms of human intelligence. And today, I ask the question because today we are definitely in the spring. There's a lot of enthusiasm about the idea of artificial intelligence, and there's reasons for that. Because today we talk of algorithms rather than computers. You know why, but we can discuss it. The approach about reproduction intelligence is in any case quite similar. The ideas, the algorithms are nowadays present everywhere, also in our daily life. And the way to work with algorithms inherits and develops the idea of producing an artificial intelligence. And therefore, the advance of artificial intelligence seems today to have a really unprecedented momentum. The algorithms can do more and more things and do them better and better. And in particular, there's a connection with artificial intelligence. Algorithms are able to perform tasks that were up to now the prerogative of human beings. And we humans do them thanks to our intelligence, do them as intelligent beings. Algorithm can now, as you know, we explain it every day, they can answer the phone, give information, carry on conversations, but they also, as you perfectly know, can write text that in many cases are impossible to distinguish from text produced by human writers. There are hundreds of titles of Amazon who has completely been written by algorithms, robot journalism is everywhere nowadays, and in many cases we don't even notice it. Algorithm can compose poems, can compose music, can recognize and produce images, can provide psychological counseling, and so on. We know that. And that's, of course, as I said, supports the idea that have become intelligent. But to answer the question, we have to look a little more into how the things are developed and why right now we have this impression that the machine can reach the goal of reproducing human intelligence. And I will refer to two interrelated factors, two recent developments that are on the basis of this new development, which you know, but I need to mention them to build up our discourse. One is more traditional, the other one is rather new. The first one is, of course, the huge advancement of machine learning in the last, let's say, 15 years. Machine learning is not new. Machine learning has accompanied artificial intelligence since its very beginning. One began talking about that already in the 50s and the 60s. But today something new is happening. Man speaks about autonomous learning by the machines. Algorithm seems to be able not only to learn, which is not so new, but to learn by themselves. They decide autonomously what to learn and how to learn it. There are techniques like unsupervised machine learning and especially the much discussed deep learning, where machines learn to perform tasks in ways that were not planned by their programmer. And then in some cases, the highly debated opacity of algorithm we're talking about with Chantelle, in some cases, and in more and more cases, can be even incomprehensible to human beings, including the very programmers to design them. That's a more tricky issue. Even the programs who design the program, in many cases, cannot understand how the program performed that task and the tools they developed to do that. And this is an important innovation, but it couldn't be developed without the second one, which it has to be always be connected to understand what's going on, and also very much debated. Machine learning, as we know it now, wouldn't work without big data. Big data, of course, in general, one refers with big data to the huge amount of diverse and heterogeneous data that are available today for the operation of the machines, for this algorithm, usual machine learning. And as you know, the definition of big data is highly controversial. It's very complicated. There are all these formats, the V, velocity, variety, and so on, and the debate is still open. And it must be open, but I want to refer to a specific point on which I think everybody agrees. Big data, this new kind of data, are connected with the spread of the web 2.0 or 3.0 develops, but participatory web that we know since 15, 20 years. The reasons is that through the participatory web, each of us produces every day a lot of data, either voluntarily or in an automated way, sometimes not even knowing about it. But in any case, the data, they go and produce the big data, the heterogeneous, strange data that the machine uses. And we do, as you know, with our behavior, with the navigation and choices we make on the web, with our participation in social media, but also without knowing, for example, with the data collected by GPS services or by the Internet of the Things and many other sources, sensors everywhere. In any case, we produce a lot of data that go in the web and are used by the machines. And the result of this innovation is what we said before. The machine now can perform many complex tasks that previously required the contribution of intelligence. And so, of course, the conclusion seems to be quite straightforward. Is the machine are now able to perform autonomously the tasks that we perform with intelligent, should be computed, the machine have become intelligent. Our algorithm finally fulfilling the dream of artificial intelligence. That's not how I see it, and that's what I want to discuss with you. And actually, it seems to me that the very idea behind artificial intelligence is no longer appropriate to describe the situation we are facing today. I say it a little provocatively, but that's the point I would like to discuss with you. Because if you look at the work of recent algorithms, you can see these machine learning algorithms are used with data. You can see that intelligence now is neither the point nor the purpose of the algorithms. The machines, that would be the statement, can do such amazing things, not because they're finally become intelligent, but paradoxically because they're no longer trying to be intelligent. They are doing something else. Or even more extreme, I think I could say that the advances we observe today do not mark, as many people say, the triumph, the accomplishment of artificial intelligence, but in practice, I would say the abandonment of that very project. I explain it now with some examples. The algorithm, the processes that drive this algorithm are now completely different from the process of the human mind. And in fact, as we said, no human mind or combination of human mind could reproduce them, and in many cases not even understand them. But programmers are not surprised. Many of them explicitly say it. Already in 2012, Solon, a programmer, said that we don't try to copy intelligence. That would be too heavy a burden. And we don't even need it, as many programmers nowadays say. An example that I often quote, because it seems quite clear to me, is something you all know very well, and the example of machine translation, which now works very well. I use it very often. And I remember 15, 20 years ago, machine translation programs were sort of useful, but produced this strange text that in many cases didn't make any sense, cannot be used in a reliable way. But now they can. They produce excellent translation where you change the details, but the texts are very useful. And the programmers say it explicitly. They recognize now they are working much better, but they say that works so nice since the moment in which programmers stopped trying to teach algorithms the different languages and the rules of the languages. Today, algorithms, for example, translate text from Chinese without knowing Chinese, and neither their programmers do know Chinese. They do something different using machine learning and big data, as we said. They just find that are the catch words in the field, patterns. They find patterns and regularity in the huge amount of text that they find in the web. And thereby, they use these patterns to produce text that makes sense. But they make sense to us, to the users, to the people who ask for the translation, for us, to the people who read this text, not to the algorithms. Algorithms don't understand the text they produce. It's just as they don't understand anything about the content they process, and they actually don't need to do that. And that's an approach that we find in other projects. For example, spell checkers that also work very well today, they correct the typographical errors in any language without knowing the language, without knowing the rules of the language, and without knowing the text that they are dealing with. Or digital assistants like Alexa and Siri, they talk with us without understanding the meaning of the word they say. And even the algorithms that produce text, very widespread today, as a programmer said, I quote, don't reason like people in order to write like people. They do something different. So machines, I would conclude, didn't learn to think like us. On the contrary, they do no longer try to do so. And that's, I would say, that's the reason, that's precisely the reason why they work so well. We are dealing now with a big novelty, but mostly because we are facing a way of processing data and emerging information that is basically different from human information processing and very different from our understanding of text. And this is my point. I think that this difference, the difference from human information, is not a weakness in the way the algorithms work, but the very root, the very reason of the success of the new technologies. I often use a metaphor by the German philosopher Hans Blumenberg, who said that humans learned to fly when they abandoned the idea of building machines that mimic birds and flap their wings. That's not what airplanes do, but airplanes can fly, and we can fly with airplanes. They don't behave like birds. And I would say that the same way, digital information processing achieved the result that we see today when it abandoned the ambition to mimic in digital form the process of the human mind. That's not what algorithms do. Of course, there can be objection. And the first one that we often hear is that algorithms, which is true, algorithms pass the Turing test. They do it every day nowadays. And the Turing test has always been considered the criterion for determining whether a machine is intelligent or not. You know how the test works, and the idea is that the machine passes Turing test if it's able to communicate with a human being without the person realizing that his or her partner is a machine. It has been always considered a test for artificial intelligence, but I always thought that if you think about it, it's a very strange test. In fact, it doesn't measure in any way the intelligence of the machines, but measures something different. It measures the ability of the machine to act as a competent and informative communication partner. And that's what the project of artificial intelligence led us. It led us to the point that we can build machines that actually didn't learn to become intelligent, but to do something else, which exactly is what Turing test measures. And something that human beings do with their intelligence, but the machine do it something a different way. Machines have learned to participate in communication. And that's why, as Chantelle anticipated, rather than artificial intelligence, I prefer in this field to speak of a new form of this really radically new artificial communication. What the machine learned is to communicate, not to become intelligent, because they don't need to be intelligent. Of course, this does not mean that human intelligence has become irrelevant. On the contrary, for this kind of artificial communications, human intelligence remains indispensable. Machine learning algorithms work very well, but they can compute, combine, and process different information they found in the data with amazing efficiency. But they cannot produce this difference, this information, the data, but on their own. They find them on the web. And they find them because they are generated by ourselves, by the behaviors of humans. Through big data, algorithms feed on the differences generated by individuals and by their behavior. And they use them to produce new, surprising, and in many cases, informative information, instructive information. Recent algorithmic processes, that's the novelty of the new procedures, they start from the intelligence of users to reprocess the result of this intelligence, and they operate intelligently, but as communication partners, without being intelligent themselves. That's why access to the web is mandatory. In order to participate in communication, these algorithms need to access the web. It wouldn't be possible without the possibility to feed on this information that we produce. And that's why the breakthrough, this new spring of artificial intelligence, only came about when human behavior went online, the participatory web, Web 2.0, and in a way that our behavior started producing all this big data that algorithms use to guide, to learn, accomplish their operations. In this case, as in many other, I think the emblematic example is Google. Google, I think, has become so successful because it was the first to systematically adopt this kind of approach. As many people say, Google's PageRank algorithm invented the internet as we know it today. It has been some years now, but I think the approach is something that really marked the difference in the way we deal with the internet and the way that algorithms work. Because PageRank relies on a really very inventive and sort of genius, powerful intuition. Because PageRank was different from the other search engines that we knew at the time, like Yahoo or AltaVista and so on, because it was the first who explicitly gave up the goal of understanding what the web pages say and decided to rely only on the structures and the dynamic of communication. That's my way of describing it. But the point is, when we search for something on Google, to determine which pages are important and to whom, PageRank does something really inventive. Doesn't try to figure out what the pages are about or how they talk about this topic, but instead goes to see how many times they've been linked to and by whom. You know how PageRank works. So Google uses the links to learn how important the page is, but also what it's about, to learn everything, what builds up the apparent intelligence of the system. If a link links to a particular page uses a specific phrase, the system deduces that the phrase actually describes that page and takes that into account for subsequent searches. So the algorithm PageRank is designed to capture and reflect the choices made by users. Or as John Gianandrea, which was chief engineer at Google, said, when a user, each of us, does, for example, a search on Einstein, Google does not intend to tell you actually what is important about Einstein. It intends to tell you what humanity is looking for when searching for Einstein. So the intelligence of the system in all these cases remains the intelligence of the users, and the algorithm exploits it to direct and organize its own behavior. This is Google, but not only Google. Google has become the prototype of an approach that now can be found in many other processes on the web, and not by chance on the processes that are often particularly successful. There's even the term since 2003 that has been used, like Googleization, has been used to describe the spread in many more, in an increasing number of applications and contexts of models like Google, models that do not rely on traditional experts, but like Google, so say, feed on the dynamics of the web, so on our communication, to organize the operation of the system and to learn from the system. This is the reason why I propose to shift from intelligence to communication, but of course it leaves many questions open. Mostly, why is it useful? What does change? What changes if you accept this communication-oriented approach? What do we see, not see, or see differently if you observe algorithms shifting from the reference to intelligence to the reference of communication? I want to test this approach on a problem, which is maybe the main problem now dealing with algorithms, which is, as I said at the beginning, the very much discussed opacity of algorithms. This lack of transparency of the procedure of these most advanced algorithms, in many cases, is seen as the most important challenge, as the real challenge that machine learning and data techniques pose to society. To put it in a question, if machines work in a way that is different from our intelligence and is often incomprehensible to us, how do we control the results of their operations? Because let's assume algorithms are very efficient. They are in some cases not, but let's assume they work well. Even if they are efficient, they work well, they are, as we know, black boxes, as Frank Pasquale and many others say. And that they are black boxes is not at all reassuring, especially because we know that their operations are not immune to biases, to mistakes of various kinds. And in many cases, my project on prediction was, for example, on precision medicine, and that's fit or precision medicine, we work also on predictive policing. There are two typical cases where we would like to verify, to be able to control the correctness of the results of the algorithms. Because as we know, they might be wrong, or even if they're right, they might be inappropriate in many different ways with often very serious consequences. So to know that, we have to deal with this problem of the intransparency of the algorithms or opacity and so on. And we know what the problems are, also very much discussed, like overfitting, algorithm blindness, different forms of bias, systematic bias, confirmation bias, data bias, and so on. So we have to want to deal with that. And also, we would be able to verify the results produced by the algorithms, by these black boxes, and check the way they were obtained, how we deal with that. And that's what I would quickly deal with in the last part of my talk, the question of how can we explain black boxes. Explaining, not by chance, because there's this recent branch of research of explainable AI, where people are developing procedures to explain the operations of self-learning algorithms. And they produce many interesting results. But of course, the goal, the purpose is sort of hopeless, or in any case, very complex. Because in case of the most complex and most efficient algorithms, this self-learning or even deep learning algorithms, there is, of course, a basic obstacle. Because if by explanation we mean a procedure that allows human observers to understand what the machine is doing and why the machine is doing it, the effort seems to be hopeless. These recent algorithms that seems to be intelligent are, as we know, and even as programmers clearly say, they are inherently incomprehensible to human intelligence. David Weinberg says, for example, that required explanation of this, the work on this algorithm would amount, I quote, to forcing the AI to be artificially stupid enough for us to understand how it arrives to its conclusions. And that's not what we want, of course. The strategy must be different. And here is, I want to test the approach shift into communication. Many project on explainable AI. In BLF, you have a great project, 12 years with many sub-projects on explainable AI, and observing what the people are doing in the field. I think one can say that they are now, without explicitly theorizing it, but practicing the way they work, they were taking a different approach that I think is compatible with this radical obscurity, opacity of the algorithms, and also consistent with the idea of focusing on the capacity of algorithms to participate in communication rather than on their intelligence. And that is sort of contradict the name, which they talk of explainable AI, so explainable intelligence. But actually, I have the impression that these projects are not really concerned with machine intelligence. Rather, the goal is, sometimes said explicitly, is to produce a condition of dialogue between the algorithm and the user. A dialogue in which the machine provides responses that take as input the always changing requests for clarification by their users. Or, as we can say a little more theoretically, the goal is to produce machines that are able to participate in a meta communication. So a communication about communication. A meta communication that can have as its object the process of the machine or the data the machine uses. But the goal in any cases is not and cannot be that the users understand these processes, understand the intelligence of the machine. The goal is not producing a transparency of the operation of the machine, because of course that obviously is impossible, but something different. To produce a condition by which the user can interpret what the machine communicates about them in such a way that a form of control can be exercised. So machine, I would say, must be able to produce adequate explanation responding to the request of their interlocutors. That sounds very abstract, but I'm a communication theorist, and I think that actually is not so new, because that's exactly what happens with human beings as well. We also do think and make decisions, and we might be asked to give explanation of our decisions. And the purposes of the explanation we are requested to provide is that the recipient, our partner, can understand our decision so that the person can make sense of that and reply, comment, object, and so on. But what information do we get when we get an explanation? We continue to know nothing about the neurophysiological or psychic process of our partner. These processes, fortunately, we say, can still remain obscure or private. To give a good explanation, we don't have to disclose our thoughts or the background of our thoughts and precisely what we are thinking, and even less, we have to disclose the neural connections in our brain that produce this thought. We need to provide something else. We need to provide the partners with additional elements that should enable our partner to understand, but from their perspective, what you have in mind, what you have done, actually. Here refers to Luhmann, who said that explanations are reformulations with added benefit of better connectivity. So the idea is the sender, if you are asked for an explanation, you produce a new communication that provides additional elements, added benefit, additional elements they are related to the specific request to the need of our partners. And in any case, the process is completely entirely communicative. We do not need access to the brain of the partners. We don't need access to the minds of the partners. We only need to get additional clues that allow the communication to go on in a controlled, non-arbitrary way. So the idea is the partner should understand enough in his way to respond, to object, to elaborate, to control what's going on, not to read our minds, not to know our neural processes. And I think that the same approach could be very useful if it can be taken to address the dilemmas, the apparent enigma of the request of transparency, which makes actually no sense, or the dilemma of explanations in interacting with the self-learning algorithms. Also, in these cases, the issue is not to reach transparency, but rather to make these machines that might be opaque, in many cases not even opaque, but nevertheless transparent to us, that make this machine produce, I would say, reformulations of their processes that match the demand of their interlocutors. So that the partners, the users, can exercise the form of control which is appropriate in the specific context, think about medicine or policing or our everyday needs with the machine. So the user should be able to explore and verify what the machine has done. And there's elements, clues that allow the user to do that. Basically, the question is not to reach a transparency, not to make us able to understand how the machine works, but rather to reproduce with the digital partner the communicative situation in which explanations are requested and provided between human beings. Reproduce with the machine a communicative situation, not a transparency related to the operation of the machine. And that's actually, it seems to me, what's going on in many recent XAI, explainable AI projects. Not without a real theory about that, but in practice, what programs are doing seems to be to go in this direction. They do not try to make the process, the calculation, made the machine understandable. As I said, that would amount to simplify them so much that they will become more stupid and don't reach the results that we need, and that's not what we want. We don't want to give up the efficiency of the machine. But rather, they are making an attempt to make the algorithms produce what they call post-hoc explanations that I assume reproduce what happens in communication. That's what we do when we give explanation, because the processes by which we explain our decision are distinct from the one by which we make them. We first make a decision, and then post-hoc, we produce an explanation when it's required that is explained to someone what we have been done. So explanations are produced later. And explanation, the reason why that's important, the post-hoc, they don't make the machine more stupid because the explanations don't affect the decision-making processes. They don't make the process more efficient, less efficient. The machines do what they have to do, and then they can produce post-hoc explanation when they are needed. And that's what people are doing in explainable AI. They are training the programs to produce this explanation that reformulate as posteriori, so post hoc, how the machine works, and that doesn't affect the performance of the machine. So an effective explanation doesn't need that the partner knows the operation of our neurons in human beings. In the same ways, these processes that should be applied, the explanation with the algorithms, don't need transparency on the operation of the algorithms, are different from the process by which algorithms take decision. Some examples that we experimented now, but I think there might be much more, are they use machine-produced verbal explanations or visualizations. Visualizations are so important in the field. You know it perfectly well. Or local explanation like saliency map that highlight the most significant element, the clues the machine is using. And of course, that the user can understand them in a different way. So summing up, I think that in this case, what's interesting is that what the user understands of the explanation of the machine need not be the process of the machine. You can understand an explanation without understanding how the machine works. Or summing up with my words, what these programs accomplish when they produce explanation is not an alternative form of intelligence, but again, an alternative form of communication. And I think that's well, the perspective I would like to work on, and that I would like to discuss with you. Thanks so much. I think I'll stop the screen sharing.
Thank you so much, Elena. I think that the first thing that comes to my mind in terms of your project, or maybe the kind of overriding question is, if algorithms are our new communication partners and learning from us in these very interesting ways, you know, what are we learning from them in turn? And I think that that's quite a big question. But I think that is what your work starts to try and grapple with in moving, you know, in shifting the conversation from intelligence to communication. I think that that's kind of, that's one of the things that it allows us to start asking.
May I? Yeah, that's very quickly, that's a really important point, and I agree perfect. That's an interesting issue, but that's what's already going on. Think, for example, of the much discussed case, AlphaGo, the algorithms that learn to play Go, and plays Go it doesn't know the rules of the game. It plays in a completely different way than the Lise doll, the other master that were playing with them. So it's completely incomprehensible in a sense, but the machine produced this way of playing Go that the master used to improve their playing technique. So what happens in many fields? The machine works a different way than us and produce clues that, of course, sometimes we can explain them, and that's also a posteriori, and that can also be, causality in the algorithms can be derived a posteriori, not a priori, or we can use them to learn to develop our own procedure in a different way. That's the interesting point. It doesn't rule out our intelligence with the process of the machine, but it's a different way to deal with them, a way that requires a sort of by which the opacity of algorithms is not necessarily an obstacle.
Yes, absolutely. I'm going to ask Nico to respond to you quickly. I think he's prepared a couple of questions, and after he's spoken and you two have been in dialogue for a couple of minutes, I'll open the floor for other people who want to ask questions.
Thank you very much, Chantelle. Elena, thank you for your very fascinating presentation. If you say that artificial intelligence or artificial communication are provocations that can generate new communications, and I think that certainly your book and your work is in itself also a provocation that is, as our conversation now proves, is provoking and generating more communication. I want to start with a few quite simple or basic questions. You began your presentation saying that algorithms on the web feed on users. It feeds on difference and processes that, but then of course the output that comes out from there, it also produces difference in this way. This is, I would say, what the communication, one definition of the communication would be, is that it's producing difference. Then within Luhmann's conception of communication, of course, if we're faced or confronted with a communication, it also demands something of us. On the one hand, we can understand or misunderstand that. And on the other hand, we have to accept or reject that. And as you pointed out, often the processing that went behind the communications are inaccessible to us. So on what basis are we able to this demand to accept or reject? On what basis can we do that? Something that we per definition cannot understand, because even if we have the self-explaining artificial intelligence or artificial communication, that explanation is of course also not understood by the algorithm itself. It again depends on human reasoning to make sense of that. So if I may ask it in two parts. On the first point is, how on what basis do we accept or reject communications? And then importantly, and I think this is also where the ethical aspect comes in a lot stronger, is who makes those decisions? Who are the ones communicating with the algorithms? So that's just two related questions that I would like to serve first.
Can I reply now? Well, thanks so much, Nico. They are great questions. I'm really happy to be able to refer to the background of the entire idea, which is Luhmann's concept of communication, as you recognize. Also, there are provocation, irritations. That's comes from this background, and I think that's a very productive starting point. But yeah, a difference between accepting, rejecting, and understanding. That's not my idea, that's Luhmann's idea. And on this point, I basically, well, of course, Luhmann never wrote about algorithms because unfortunately he died before the algorithms were really widespread. He produced some really insightful thoughts about the social communicative meaning of computers, but not the algorithms now. But the way I apply communication to algorithm is, well, completely referring to his theory of communication. And Luhmann made a clear separation between understanding and acceptance or reject or refusal of communication, which, by the way, is the big difference in the debate between him and Jürgen Habermas. We said that accepting consensus is part of the communication. But Luhmann's idea, I think, is quite basic. He says, to understand the communication, you don't have to understand what the other person has in mind, because let's say we communicate now, and if I understand the communication goes on. If the communication is successful, it's not because I know exactly the thoughts that Nico had or someone else had. He might be in a good mood, in bad mood. He certainly have many references that I don't know at the point, but he just has to produce something which the concept you mentioned irritates my thought and triggers my thought to produce my own further communication, further information. So I don't have to understand, I have to understand the communication. I have to understand in the sense that the communication makes sense to me, but in order to understand the communication, I don't have to have access to your thoughts. I don't have to understand your thoughts. This understanding is independent from accepting or refusing, because in many cases, the communication goes on and I don't even have the question of accept or refuse it. I can, in some cases, where I can reply yes or no, and this is not for the communication itself, but for society, a big problems. In Luhmann's theory, as Nico knows, there are specialty called symbolically generalized media that cope with the problem. In some cases, we have to, especially with the communication are particularly unlikely and complex or difficult to accept, like, for example, scientific communication that tells us that, that it's not that the sun rises every morning and falls and around the earth, but on the other way, that it works in the other way around. We need something that allows us to accept the communication or increment the possibility to accept the communication, and that's scientific communication, scientific truth, and the way this communication is implemented, or in the same way, money or power and so on. That partly answers to the question you were asking about the who. So acceptance of communication is a different problem. First, we have to understand what people tell us, and then in some cases, we can ask the question we accept or not. In many cases, we simply go on with that. And I think the same thing is with algorithms. When the question of acceptance or refusal of the proposed algorithm is asked, we need to have something like explainable AI. We need to have something, we produce a meta communication, also in our normal communication. If you are not sure about acceptance, we talk about the communication and require additional elements. And that's what explanation produces, I think, in both cases.
Thank you very much. I would also like to ask something else that your presentation perhaps didn't focus so much on that, but that's given quite some space in your book, is what you call through education, through this feeding on user feedback on the web, how, and this is now a very, since 2016, I think, a problem that people have been speaking about very commonly, is what is commonly called the echo chamber or bubble effect, what you call and I really like that, the demasification of media. The idea that we're not all exposed to the same mass media, but we all get personalized media, and that in this process, the public-private distinction is becoming blurred to the point where the public sphere is disappearing completely, perhaps. So if that is happening, if the public square is gone and we cannot all refer to the same shared reality increasingly, what are the implications for that, for the individual as an ethical subject?
Well, that's of course is a huge question. And the ethical implication, I would be delighted to discuss with people who know more about it. But what I think we as sociologists, the communication theory, have to deliver is a proper description of what's going on. I agree with you. We don't have it yet, because you probably remember when the Web 2.0, the personalized web, was produced around the 2000, there was the idea, which is plausible but wrong, that now everybody will be able to personalize his or her own communication, and that we will freed from the bad condition of being couch potatoes, that people can be active, and everybody will be so happy to have his own communication that reflects exactly our interest, our inclination, and what we are interested in. And so the idea that instead of having the newspaper that informs us about many things we're not interested in, for example, sports we never follow, or the English royal family or whatever, we only have the information we're interested in. And that's plausible, but we know as sociologists, that's not the point, because the mass media, on that Habermas was right, are the basis for building what has become a shared public opinion, shared public sphere, by which we want to know not exactly what we are interested in, we want to know what other people know. And that's the basis of public sphere, basically about mass media. The mass media are useful because we want to know not only what we are interested in, but what other people are knowing, and not necessarily what they think about, but what they're informed about. And this is what the personalization of the mass media is jeopardizing now. Because personalized media, well, first, the idea that people are active is sort of an illusion, because when we get personalized media, we're not active at all. It's just the algorithm that personalized media for us, and we are just get passively something which is individualized, but not more active than we got from the traditional broadcast media. But moreover, as you say, the issue raised emerged of the so-called filter bubble, or new ways of, we are closed in our bubble of information that apparently informs us and interests us, but it's also sort of claustrophobic and so on. And well, I don't know what's going to happen, but what we can observe now, that nobody is really happy with the filter bubble. There are many trends that go in a different direction. Also, the many news feeds, the new ways of reproducing a kind of equivalent of limited public opinion, public but not completely public, show that our interest is not only getting what we're informed on, but knowing what other people are looking at. And that's the social aspect of this, which is completely moving now. As we know, in the political consequences, polarization, so on, there's a lot of things going on, which in any case force us to abandon the simple idea, generalization, personalization is the opposite. That's a lot of what's going on in between these two poles. And that's really exciting now and extremely complex.
Thank you, Nico. I don't know if you wanted to make a last comment there. That was a really good question.
No, I think maybe later I can jump in again, but maybe I should let others have their say.
Thank you.
Thank you.
So I'm going to open up the floor for questions. If any of you have questions, if you could just raise your hand. Aragorn.
Yeah, can you hear me?
Yes.
Okay, my questions are a bit all over the place, so I hope they make sense. I'm coming at this from a background as a software developer, so I'm very interested in some of the technical aspects of machine learning. but the first question I had is, when we think about sort of communication and maybe what we can impute about the ways in which aggregated data is being represented by machine learning. I wonder if there's any merit in looking at the output of machine models like GPT-3, the language engine that produces natural language that's particularly convincing in some cases, or looking at sort of the visual machine models like Imogen and DALL-E and stuff like that, where you can describe, a cat riding a skateboard in space, and it'll generate this photorealistic image of exactly this thing. But there are also certain ways in which these machine models fail dismally. So, for instance, if you give GPT-3 a sample of James Joyce or William Burroughs, it's not going to successfully reproduce any sort of output that matches that style. So I was wondering, as a first question, if based on the fallibility, the limitations of communication of these machines, you can also start to in the process of that training, of that learning. I don't know if that makes sense, but the second question was the more important one, actually, which is, it's a question about the neutrality of communication. And if we observe the obvious fact that communication obviously always occurs within the context of power and certain hegemonic relations of dominance and submission and everything else, there's a natural tendency to assume the merits of the kinds of outputs we receive from machine models because they're associated with science, technology, big corporations, power, everything else, right? Computability, all these things that we assume are inherent, right? So in that sense, I wonder if there's like an important political point to be interrogated here around the communication as what Deleuze and Guattari would call order words, right? So that it's not just sort of neutral communication, but it's actually an injunctive communication, right? It's instructional. It affects an incorporeal transformation. And I think that's really important because I think there's a way in which, the sort of whole assumption of how machine learning works is actually reversed on a social level. And that there's a reciprocal training taking place where the more we start relying on these machine models, the more we're being trained by their outputs, which are a quantified statistical aggregation of data that has its own assumptions about the form of salient questions and the form that human thinking and human communication should take. In case that's very opaque, a very simple example of this is predictive text, right? The more we rely on predictive text, which is based on machine models, the more we conform our communicational style to the style that's presented to us by that predictive text, because we assume it as an inherent good. So I was just wondering about this sort of political subtext to this and the way in which our communication is conformed by the approach implicit in machine learning. Yeah, that's it.
Yeah, again, thank you. That's a very, very important broad points. I cannot really answer them extensively, but I can say something about it. First, unfortunately, or I myself are not able to program. I don't know, that's something what decision some times ago that I observe. I'm working very much with the programmers, but myself, I cannot program myself. So I try to observe with their head what's going on and get clues that sometimes knowing to do that can produce kind of blindness, but in any case, it's a different approach. And what I could see without, well, I said, really say once more, without any competence over technical details, what it had been observed many times working with programmers is that, well, again, also in the case of image recognition, the famous cat faces recognition, the machine actually works different from us. It doesn't recognize the face of the cat, but calculates in its own way the element that are sent for the machine and produces a result, which is often appropriate, but the real interesting point is that's not generalizable. So the result the machine produces is individual, for example, what's important in the case of medicine, produces a result which is appropriate for that specific case with a specific database, a specific question. And the machine had learned nothing. The machine had learned to recognize faces of cats, and the machine has to recognize faces, let's say, of horses, of dogs, instead to start afresh completely. So it doesn't learn. It learned how to deal with the data. It doesn't learn any concept of cat face or any concept of face that it can use for other approaches, and which is a big weakness in the way the machine works, but also a big advantage it's a completely different way of working than human beings. And that's something you have to take into account dealing with that. So the question about neutrality and power, sometimes I lost your voice, I didn't hear anything, but as far as I could understand, it's again, a really, really important question. Of course, I would say it has two dimensions. One is the simply matter-of-fact monopoly of the big companies like Apple, Google, Facebook, and so on, which they happen to have, without any real ground, a real big power on the way we deal with the data. And but at the same time, we know that the situation is more complex than it was before, because even if this power does not necessarily imply that the results will correspond to the expectations. Because we know dealing with big data, you never know what the machine finds. You will remember the case of TAFE, for example, by Microsoft. The algorithm was meant to be sort of liberal and open and so on, and it was rejected after a couple hours because it produced terrible racistic, sexual, terrible oriented results. So the data, the machine worked with the data, and the big data are by themselves uncontrollable. Not even the programmers of the big firm can know what the result will be, because the algorithm, the machines are certainly biased, but a big source of bias are also the data that cannot be controlled, and the result can often not be what the programmers had in mind. Nevertheless, what you are dealing with, if I understood it right, is an important question. How we deal with prediction? The predictions that the machine produces are often in transparency, and as we know, they project to the future something that comes from the past. So it can be a kind of inherent continuity and or sort of a conservative attitude that we might inherit without being aware of. And that's an important point, but also not necessarily, also one on which we have to rethink our categories, because the algorithm often find patterns which are not the patterns that reproduce. The patterns the machine finds are not the pattern that we were aware in the past. They find structures in the data nobody was aware of. And so they, in a sense, they are creative. They find something that, think about distant reading or what people do in the digital humanities. The machine are, in a sense, creative, finding in this big mess of data pattern of structures that were not there before in the sense we understood that. They just find something new, which, as Chantelle already said, has then to be worked out by us to make sense, because many of these patterns are, as we call, spurious, don't make any sense. But if they make sense, they can be genuinely creative in a way that doesn't necessarily product the structure that we had in the past. But it's very complex, diverse condition.
I think part of what makes it so hard is that it's just unfolding in front of us, and we have to continue understanding it as it changes at this very fast pace. And so our theorizations often kind of lag behind a bit. Steve, I see that you have your hand up.
I do, thank you. And thank you for the talk, and hello everybody. Yeah, Steve Watson. I work in sociology of education in Cambridge. Although in Sheffield at the moment. So, but that was very interesting and made me think quite hard about, I mean, certainly often thinking about technology around education and what, and aspects of that. And in a previous life, I was an engineer, so I've kind of gone round in a big circle from engineering to sociology and probably back again. But one of the things that was making me think, what it was making me think about is machine learning algorithms in the context in which they use as an evolutionary projection of language. In that what we might have here is a dynamic and self-referential system of grammar. And I think one of the, the long-standing issues of language was coordination between individual consciousnesses and while maintaining a language that can be shared across groups. And now that challenge becomes specifically acute, especially through modernity. And of course, we see in the only language that I can deal with is English. The codification and the need for a grammar, the need to have a second order observation of language in the 18th century, I suppose, and then the inadequacies of those grammars, especially when we retrofitted Latin grammar onto English, and the problems that then ensue, and some of the political aspects of that, I suppose. But increasingly, the way in which languages try to engage with its own structure has become more sophisticated. All the kind of the linguistic research and the kind of pragmatics. And I think originally computers were looking at inherent structures of language. But what an algorithmic approach using machine learning perhaps allows language to do then is to actually look at the whole, a whole range of communication and see the inherent structures that are being used. And we're not talking about words, we're talking about a tweet or a TikTok thing, whatever you might call a singular piece of TikTok. And I think the algorithm is then probably a structural device rather than a communication device as such. Yeah, that was just what it made me think. I don't know if that, if you've got any thoughts about that.
Well, I think it's really fascinating, and I know I got what I got because it is a field that where my competence is limited, but it's really, really fascinating when you talk about the grammar structure of language. And I would agree that when you say algorithms have structural influence, and not a communicative one in a sense, but and how they affect the way we communicate, nevertheless, I see the complexity. I don't necessarily see the problem because as I see it, well, again, answering Chantelle's initial questions, algorithms think about, well, for example, I've just mentioned distant readings on, make the structure in the communication can be more complex in a way that partly are transparent to us, but still someone has to understand what the algorithm says and said in our way. I don't have to understand the algorithm, I have to make sense of what they're going to produce, thereby I produce further communication that complexify the social structures. So algorithm says, they don't have to, in my understanding, they don't have to follow grammar in order to affect the grammar of a language. They work as they work, and the language will, if it does, as in the case of Go, use them to produce forms of communication, forms of information, forms of processing data that wouldn't be possible without the algorithms. But the structure of communication remains communicative structures. I would say that's the fascinating of the algorithm, that they don't have to think, think about the thinking. They have to think like us to let us think in a more complex way. So algorithms have to use language like us to make our language develop in a more complex way.
Yes, I suppose they're looking at the patterns in the language, in patterns in communications that are being used, and those patterns become a de facto grammar. That then is something that can be shared, but also is constantly connecting to the individual consciousnesses. But that's, better let somebody else go.
I think we agree, but the question is whether we define the terms of what is grammar.
Yeah.
I think the empirical you're observing is similar. For example, when Franco Moretti finds structures in thousands of books that couldn't be grasped by the human reader, it gets some information that then, of course, by themselves wouldn't make any sense if someone doesn't understand, a scholar, and understand a way of connecting this huge amount of text and to work on them, that wouldn't be possible without the algorithm. And that's what we call grammar. So it's open, of course, but the empirical phenomenon is something new.
I wonder if then, like hieroglyphics became redundant, that words might become redundant, ultimately. Since we're in a predictive mode.
Yeah.
Thanks, Steve. Very interesting. Yeah, very good observation and great question. I wonder if I can ask a question. One of the things you didn't talk so much about today, but that is really in your book, is also, and maybe that links to Steve's question, is, we're also using a lot more visualization. We're taking all these photos all the time. If we think about our cell phones really interest me in terms of, we can call them communication partners, but also in terms of algorithms, the way that we've integrated them so almost seamlessly. It would seem seamlessly. Of course, it wasn't seamlessly. There was it was quite difficult in the beginning, but now it seems like it's seamless. And one of the things that also interests me is what this is doing to our conceptions of time, and temporalization. And so you actually talk about this, that the way that we take photos these days, and I think often even the way we communicate, isn't for temporal preservation, but for social multiplication. And I wonder if you can say a bit more about that.
Yeah, thanks a lot. That's something, it was a proposal that is not completely elaborate, but I wrote it because I want to propose to the general discussion. And it came from a simple empirical observation that we, in my generation, we still we're educating the idea you take pictures to preserve a moment in past, to memorize in a sense, to preserve a memory, to keep it. And if you look what's going on the web, it's completely different, of course. I observe my daughter and this new generation, they take photo. Think about Snapchat. The photo is taken to be shared and to be destroyed immediately. It's not preservation the goal. And of course, young people are not stupid. I'm always amazed how clever these digital natives are and what they are doing. And I was trying to observe how we can understand what's going on. And it's not worked out. The proposal I made in this chapter of the book is that sometimes, the present time can be so oppressive. Now we have the sort of responsibility of what we are doing at the moment and the consequence of what we are not doing at the time, or how we can elaborate all the information, the emotion especially we have in the present moment. And the moment goes by and something new happens immediately. And sometimes I have the impression the way people use photographs now is not to preserve the present, but as I sort of wrote in the chapter, to escape the present. It started from observation where you are you see people observe, for example, a landscape or a sunset or a work of art, which is so overwhelming. And there's so much, you cannot work it out completely. And you are all oppressed by this time. It goes by and it's gone. And then I didn't make all that I had with this moment. And I live with this frustration. But young people, they take a picture and they post it. And that's, I thought, it's a way to, well, escape the present. You just, you are unburdened by this burden of the present, you have to circulate. And it sort of can be, I just wanted to propose the idea, that's a new way to deal with the relation with the present time and the present time and the here and now situation, which is not elaborate. It seems to me in my now society to be elaborate in a different way, in a way to connect the present moment with the past and the future that seems to have new ties and new implications. That's why it was also proposed in the chapter. I connect this kind of escape in the presence with a new, well, seems to me, way that happens at the same time to rediscover the present time. For example, in art exhibits, where the curation that we now have in art exhibits are, well, sort of a way, since artworks can be seen in every time in very precise reproduction, digital with a high fidelity and so on, what is the meaning to go to an exhibit? And I have the impression that new forms of curator sort of try to produce a new experience which is really connected with in that space, in that moment, in that situation, and sort of the counterpart of what they are doing, take pictures. Just rediscover the density and the importance and the experience of the present time, curated by people in some way that will, the goal seems to be, to me, make us more aware of exactly the counterpart of photographs. And the phenomena often are happen at the same time. The one side and the opposite are produced by the same, in this case, technological innovation, but more or less a proposal.
Thanks. Yeah, I think that I find that distance quite interesting. Bernard Stiegler also talked a lot about this kind of exteriorization of our memory, which for him is one of the kind of more problematic areas in terms of algorithms, because he links it to how we don't produce intergenerational memory. And so I think this idea that you're starting to talk about and this distance is really interesting for me. So
yeah. May I comment a little? That will be very, very short. That's really important, but you have to understand algorithms as a way to deal with memory, which is the opposite of our modern one, because algorithms remember everything, not forget. Yeah. The problem is the right to be forgotten. The problem with algorithm is to make them able to forget content, not to remember it. So the entire perspective is, well, again, a real challenge to our categories.
Absolutely. Yeah, I agree. That whole, the preservation of memory, but it's a new kind of preservation of memory. Yeah. So, and I think that's part of the, part of what we have to grapple with and try and think with and about. Nico, I'm going to let you go, and then Jean, and I think then we'll wrap up. Is that good? Cool.
Yeah, certainly. Yeah, I'm just thinking out loud about what we're talking about now with the idea of memory and taking photos to not remember, but to escape our social situation. And I wonder, of course, it's much more complex what we are trying to escape, but I think a big part of that might exactly be this overwhelming communication that we're receiving, at least for myself. And I know at least one other person in this room who is trying to escape constant communication. And it's interesting now that I'm thinking of that, if, the pharmacological aspect, that what is causing our distress is also the only way that we can escape from it. And I wonder then with Snapchat, if that the self-deleting photo, if that maybe isn't that maybe some kind of grasping back to the older form of forgetting, you know, trying to, through new technology, access that kind of memory that floats by that we had before everything became archived. But yeah, okay, I mean, this is not clearly a question. I'm just communicating my own observation on the previous communications, but thank you.
A short comment on that. Yeah, I agree. I don't know how, but I think these two phenomena, escaping the presence and becoming able to forget, are connected. We are, as you say, that the overwhelming communication produces different problems, but we cannot try to lose them, to solve them using our tools. For example, the point is not trying to hide the contents on the web, to cancel the contents of the web to produce forget. It's the opposite. So in the chapter on forgetting, I try to make a point of the old idea that in order to forget, you have to multiply memories, not to erase them. Otherwise, it doesn't work. But the web works completely different from our mind. And the young people sharing memories in order to escape the present, I thought of the impression that they shift the burden from the temporal dimension to the social dimension. Instead of forgetting, I give it to my friends, or instead of remembering, I multiply to my friends, which are extremely innovative new constellations that I think are connected with the, as you're right, I agree with you, with the overburden of communication that we have, that the web produces.
Jean, go for it.
Hi, I'm Jean Dutoit from the Northwest University School of Philosophy. I love the discussion on memory as well. And there's this new trend for people to take their old Nintendo 3DSs, which has like a very low camera resolution, and to record concerts using that, and to upload these things where people really can't actually see anything. There's this it speaks to that grasping again. But I've got two questions, or two things I'm actually thinking about. And I'm very interested in your discussion as well of the Microsoft AI program that was kind of corrupted by Twitter with these fascist and racist and sexist ideas being presented by that AI bot in 2016. And we're concurrently seeing the rise of, alt-right movements and neo-fascist groups on the internet. We're also seeing like increases in teenage cutting, and the TikTok kind of choking challenge, which is the idea that children try to see how long they can hold their breath, and they end up in some cases suffocating themselves, these preteens. And again, the challenges provided by the TikTok algorithm. So I'm very worried about these kinds of patterns and mirroring of society. When you go onto YouTube and leave the algorithm running for a while, you often see these horrible things and polarizing political positions just floating to the surface. And it seems like in the use of these algorithms, we can constantly see these horrible social aspects just rising to the surface. But what I'm also kind of wondering is how these algorithms kind of reinforce subtle ways of thinking. Also how you, Elena, see the relation between like neo-capitalism and our technologies, the subtle placing individuals as data points, or as numerically understood, or as statistical. What role does that play in the development of these communication styles? Is that something that can be harnessed by malicious or nefarious parties as well? I'm just wondering how you see modern capitalism kind of engaging with these algorithmic technologies. So that's the one thing that I was thinking about. And the other, and this is especially in the first part of your talk, when you were discussing these algorithms, I kept thinking of, ant colonies that communicate in different ways. Do algorithms communicate? Is there that potential? And what would that look like? Do you think that animal cognition studies or even animal behavioral studies can give us some insights into these technological developments, kind of blending those two seemingly divergent disciplines? Do you think that there's something that can be provided by those studies to the discussion of algorithms and technology? That's my question. Thanks, Elena.
Thanks a lot. They are all very interesting points. There are 3 different points, and they're all very complex, I would say. The first one, I'm worried, like you are, by TikTok, but the things that's going on. I'm really worried, and I think that sort of resonates with you. We are not prepared to deal with these things because, for example, there's all this debate in the critical media studies about how algorithm programmers are male and white and so on, which is of course true, and that's not nice, and we have to deal with that. But that's not the point, because it is the point. It's an important point for our society. But if we were able to control the bias of male white programmers, we by far wouldn't be able to control the algorithms, because the example you mentioned, like TikTok and so on, the algorithms seem to reproduce what circulates on the web, and what circulates on the web for many reasons, also because that the preserved structure or democratic setting are related to a social situation of modernity with the check and balance and so on, which are completely now overwhelmed. So focusing on that, as good as it can be, it is not adequate to the complexity of the issue. So again, I would say we have to understand how the things, or try to describe better how things are going on, how the dynamic with the new structure of the web, with new forms of reflections, autonomy of the communication that gets spread in the web through new ways, produces new forms of, also this focus attacks on the web and so on. We don't have the tools to deal with that. And that's something we really should, as social scientists, help to that's our task, we should be able to produce. But capitalism, that's also really interesting what's going on. And what I can't really reply, but I can give you a hint. There are people studying really interesting stuff about what is called algorithmic management, how in the firms, that the structure of the traditional capitalist form, Taylorism, and whether the structure connecting with that, are now, without decision by anyone, sort of subverted inside by new forms of, it is called algorithmic management, like firms like, the example of firms like, of course, Uber and platforms and so on, but they are just the tip of the iceberg. There's the new forms of digitalization produce new ways of understanding hierarchy, new understanding belonging and not belonging, communication ways and so on. And there are people doing really interesting research on that. And I just read and try to understand it. And about animal communication, that's really a fascinating field, because of course animals don't communicate like us, but I wouldn't say they communicate algorithms as algorithms either. There's a form of coordination that requires a kind of, also irritation of the animal going on, but the algorithm, I think algorithms are different. From animals are more, animals' communication more similar to our communication than it is to the communication of algorithms, especially because in the way I understand, if you have only algorithms communicating with algorithms, you go nowhere. So they say that the algorithms parasitically feed on our communications. The algorithms, the dystopy of a world ruled by algorithms that decide everything, communicating with each other, I don't think it's realistic, simply. We have to be worried about many things, But I'm not worried about singularity. I'm not worried about this autonomous algorithm communicating with each other and overwhelming us, because it simply doesn't seem to me empirically something. There are many things to worry about, but not this, first of all, for me.
There wouldn't be much to communicate on with these algorithms.
Yeah, they are machines. Yeah.
Thank you so much. I really appreciate that. Thanks.
Okay, I think that at this point we should all give Elena a really big hand of applause. So either virtual or in reality. And also to Nico. Thank you, Nico. I think Nico really asked us like some probing questions right there in the beginning. And then thank you to all of you. I really appreciate your joining, the interesting discussion that we had. And of course, you know, the discussion for me is always so great when people participate. And I know it can be sometimes difficult online, you know, one can sometimes not feel like you're bridging the great divide, but I think that everyone here did. And so I just really want to, to thank you for doing that. Elena, I hope that we will be able to continue this conversation in some way in the future. Thank you again.
Thank you so much. I learned a lot, I appreciate it a lot. And of course, I would be, you know what I'm working on, and I would be really delighted to keep in touch. Thanks a lot.
Excellent. Thank you so much. Thanks, everyone.
Thank you, Chantelle. It was amazing. Thank you, Elena. Thanks, Nico.